Little bit.
Till now it is good, sir.
Till now it is good, Akib.
Yes, sir.
Okay. What is your Rishta experience?
So I joined the school a bit late, so I only had 2 weeks of class 11.
Okay, you only have and you didn't studied anything of class 11th on your own earlier, right?
No, sir.
Okay, no issue. So we will start with some topic which you have done in at least of CBSE level, and we will see that what is it of JEE level. We will not upfront start with very difficult questions or very difficult theory, because when you go to class 11th, it takes a while to get adjusted. Matlab 2-3 months it will take for you to get adjust to the syllabus, to the concepts, to the problems of class 11th, which are quite difficult compared to that of class 10th. So
Yes, sir.
especially in all subjects, that is the situation. So at first, some students get discouraged that it is so difficult, but those who keep on working on it and keep on studying, so finally they get a feeling that okay, this is how the subject has to be understood. So it is only a few time that few months that you have to face difficulty, and after that it will not be so difficult for you. It will be quite smooth for you. Then you can raise your level slowly and slowly, and you can reach to the higher level questions. But those who try to do higher level questions just entering class 11 get sometimes disappointment and they leave it. So you have to move step by step. As you know, if there is a person here, this is I'm making a ladder. So here I hope this is shared with everyone. This one note I'm sharing with everyone. So
Yes, sir.
if I make a ladder like this, suppose, and it's the steps are like this, and then this, and then this. Okay, and it starts from here, and the person is of this height. So he would not be able to climb it. So it is better to have steps which are shorter, and you can easily come to your goal step by step rather than never reaching your goal. So you have to move a step by step, keeping this in mind that you have a two-year period, and for that 2-year period you have to uh, keep on trying consistently. So what have you studied in CBSE class till now? Can you tell about it? Which chapter or which topic you have studied in CBSE class?
We
Sorry,
complete.
sir.
Which chapter or which topic you have studied in CBSE class of yours?
There are many chapters like
No, which you have
trigonometry.
studied, which you have studied. You have studied trigonometry?
Yes, sir. Trigonometry, quadratic equations,
Okay,
circles,
okay.
related to circles.
No, not in class 10th, class 11th I'm talking about.
Oh, class 11th, we did trigonometry,
Hmm,
sets,
hmm,
uh, relation and function,
okay,
then linear equation,
okay,
one more complex number.
okay. What about you, Rishita? What have you studied in 2 weeks?
So, sir, when I came, it was trigonometric ratios, but before that, they did relations and functions and sets.
Okay, so trigonometry you are quite acquainted with, right?
Sir, even relations and functions because I had to study them for a test.
Okay. Abdullah, you joined just now. Can you tell what you have studied in class 11th till now? Hello, Abdullah, can you hear me? Yes, Abdullah. So in class 11th maths, what have you studied till now in CBSE class? Sets, complex numbers, and relations and functions. Okay, fine. Trigo going on. तो ट्रिग्नोमेट्री एक ऐसा चैप्टर है जिसका कॉन्सेप्ट जो है कई जगह यूज होता है और जेई में भी ऐसे तो मतलब अगर कहें कि उतना इम्पोर्टेंट नहीं होता कि अगर हम if we talk about individual question, but if we talk about multi-application based question, then it is very important. So we'll discuss trigonometry in today's class. So there are some important formula of trigonometry, and it starts with this first formula, that is sine of a plus b is equal to sine of a cos of b plus cos of a into sine of b. Yeah, we can get an example for this, like we have sine 75 degree, and we don't know what is the value of sine 75 degree. So we write it as sine 45 degree plus 30 degree. Now using the formula, this mistake you don't have to do, because generally what some people think that you write it equal to sine 45 degree plus sine 30 degree, but it is not true. So yeah, as this is how we can't write it. Okay, so this is important, that this is not equal to this. Okay, so what
Yes, sir.
it is equal to? It is equal to sine 45 degree cos 30 degree plus cos 45 degree sine 30 degree. Now sine 45 degree is 1 upon root 2, that we all know. Cos 30 degree is root 3 upon 2. And cos 45 is 1 by root 2, and sine 30 is 1 by 2. So the value which comes out is root 3 plus 1 by 2 root 2. So this is sine of 45 degree, 75 degree. This is its value. So you can note it down. So this is how you can apply. This is a simple application, but we start with some simple application. So you can write it down. So I hope you have written it down. So I'm proceeding further.
Yes, sir.
Then we have an identity of sine A minus B, which says that it is sine A cos B minus cos A sine B. And then we have cos of A plus B, which is equal to cos A cos B minus sine A sine B. And then we have cos of A minus B. So it is very important to remember these identities, because if you don't remember these identities, you will feel always handicapped in solving mathematical questions. Even these identities are used in physics. So these identities are very, very important if you have physics also. And of course, I think you have science 16, so you have physics. So maths or physics, and sometimes maybe in chemistry, I'm not sure. But maths a lot, physics little bit. These identities are important. So these 4 identities, first one I wrote above, and then these 3 identities, these are very important. You have to remember them.
Yes, sir.
Now, I'm giving you few questions. Just try it first. So there is an identity like, okay, first this question. Can you find cos of the value of okay, first try to prove that sine 2 theta is equal to 2 sine theta into cos theta. So how can you prove this using any one of the above identities?
So can we use the last one, cos A minus B?
Sorry, cos A minus B.
Yes, sir.
But cos A minus B will not help you in getting this identity. I think if you see the first identity was sine of A plus B is equal to sine of A cos of B plus cos of A sine of B. Now what we have to do, we take both the angles equal and let us call them theta. So what will happen? A plus B will be theta plus theta, which is 2 theta. And here it will be sine theta into cos theta. And the next one will be cos theta into sine theta. And actually both are same, which means 2 times of sine theta cos theta. So sine 2 theta is actually 2 times of sine theta into cos theta. This you can prove, and this is also an identity which is used at various places. But it can be proved by the first identity which we studied. So you can write it. So have you written it?
Yes, sir.
Yes, sir.
Okay. So there is one more thing which is quite used other than the identities. We have many more identities. But one more thing we have which is called allied angles. Allied angles are basically a rule to find those angles which are other than 0 degree to 90 degree. Some of those angles, like if you have sine and it is even multiple of 90 degree plus or minus theta, and instead of sine I can take here any trigonometric ratio. So what we get is complement, even multiple is there. No? So we get trigonometric ratio of theta, and there could be a plus or minus sign before this, that is being decided by the quadrant. I will give you an example. And another case could be that if it is trigonometric ratio and odd multiple of 90 degree. Plus minus theta. So it will be plus minus complementary trigonometric ratio theta. And this is also decided by the quadrant of trigonometric ratio. Now, what are the sign of the quadrants that we will see, and we will see an example also here. Some of the examples, so it will be more clear. First, write this thumb rule. So I
Finish, sir.
hope you have written this.
Yes, sir.
Yes, sir.
Okay. Now, if you have quadrants, first, second, third, fourth, can anyone tell me what is the sign of the trigonometric ratios in different quadrants?
Sir, in first quadrant, every
Yes,
every
every
All
trigonometric
trigonometric.
ratio will be positive.
Okay, in second,
sine and sec are positive. Sine and cosec are positive.
sine and cosec are positive. Okay.
In third, tan and cot,
Yeah,
and in fourth, cos and sec.
Cos and sec.
right. And what are about trigonometric ratio and complementary trigonometric ratio? So sine and cos are complementary trigonometric ratio of each other. Similarly, tan and cot are complementary trigonometric ratio of each other. Similarly, sec and cosec are complementary trigonometric ratio of each other. So this is something which you have to understand. Now we will see few questions, and it will be clear to you how this above allied angle rule is being applied.
Finish, sir.
Okay. So if suppose we have cos of 165 degree to be find out. So what we can do, there are two methods. First, do it by method one. So cos 165 degree can be written as cos 180 degree minus 15 degree. Now 180 degree is even multiple of 90 or odd multiple of 90?
Even, sir.
Even
Even, sir.
multiple of. So if it is even multiple of 90, then in that case, trigonometric ratio remains as it is. If it is odd multiple of 90, then trigonometric ratio changes to complementary trigonometric ratio. So here trigonometric ratio does not change. So cos is there, it will be cos 15 degree. And before this, whether we have to put a plus sign or minus sign, it depends upon the quadrant where this angle has the tendency to lie. So 180 degree minus something, this is 180 degree. And if you do minus something to it, then that angle will lie in second quadrant. So this whole is 180 and then minus something. So always we take angle anti-clockwise positive and clockwise negative. So 180 degree and then minus 15 degree. So it is second quadrant, and cos in second quadrant is negative, because as we discussed above that in the second quadrant only sine and cosec are positive. So we can write cos 165 degree as minus cos 15 degree. Now one last task remains, that what is cos 15? So for that we will write it as cos 45 minus 30. So this will be minus, and this will be cos A into cos B plus sine A into sine B. So cos 45 degree is 1 upon root 2, cos 30 degree is root 3 by 2. So it will be root 3 by 2 root 2. Sine 45 degree is 1 by root 2 and sine 30 is 1 by 2. So it will be 1 by 2 root 2. So this would become minus root 3 plus 1 by 2 root 2. So this will be the value of cos 165 degree. Now first write this method, then I will tell you another method also.
Finish, sir.
Okay, everyone has finished writing?
Yes, sir.
Okay. So another method could be if it is cos 165 degree. So you can also write it as cos of 90 degree plus 75 degree. That is also a way. Either you write is 180 minus 15 that we did in the first part, or you can write as 90 plus 75. Now, since it is 90 degree and 90 degree is even multiple of 90 or odd multiple of 90?
Odd multiple.
Or
Odd multiple. So in that case, the cos will change into its complementary trigonometric ratio, which will be
Sine.
sine. So it will be sine 75 degree. But the sign which is before it, plus or minus, will be same, because still 90 degree plus 75 degree will lie in the second quadrant. So the tendency is to lie in the second quadrant. So the sign of cos, this cos in second quadrant is still negative. So that will not change. That was negative in method 1 also, and that will be negative in method 2 also. Now minus sine 75 degree can be written as sine 45 plus 30. And sine 45 plus 30, if you want to calculate, so we apply the formula which we studied, and we get it like this. So it will be minus cos 30 is root 3 by 2, so root 3 by 2, and sine 45 is 1 by root 2. Cos 45 is 1 by root 2, sine 30 is 1 by 2, 1 by 2 root 2. So what you are getting finally is minus root 3 plus 1 by 2 root 2. So whether you do by method 1 or you do by method 2, this is method 1 and this is method 2. In both the situations, it will give you the same answer. So you can write it down.
Finish, sir.
Okay. So now if you want to find, suppose, okay, one thing also we can do. Let us see this question. Try this. Tan of 855 degrees. What will be this?
So will
So
it be tan of 720 plus 135?
yeah, correct. Who said this?
Rishita.
Rishita. So Rishita, it is correct. So tan 855 degree can be written as 720 degree plus 135 degree. Because why we are taking 720? Because it is actually one rotation is 360 and another rotation is 720. So after 720 degree, it comes to the original place. So this is same as 720 you can remove and simply 135 degree. Because after two rotation or three rotation or even one rotation, we come to the same positive x-axis. One rotation is 360 degree. So if a multiple of 360 degree is there, then that is equivalent to the initial stage. So we can directly write tan 135. Now we can apply allied angle. So here also you can write in both the way. Either you can write as tan of 90 degree plus 45 degree or tan of 180 degree minus 45 degree.
Sir, is the answer -1?
Yeah, -1 is correct. Because this will be tan 90 plus 45 if you do. Then tan will change into cot because 90 is odd multiple of 90. And it will be 45 degree with a minus sign because it is in the second quadrant and tan in second quadrant is negative. Cot 45 is -1, so this will be -1 as the answer. Correct. Write this down, everyone.
Finish, sir.
Okay. Again, there is this interesting question. It says that find the value of A if sine 3A is equal to cos A. I'm coming from washroom in a minute. Meanwhile, you try this.
Okay, sir.
Yes. So let us discuss this one. Anyone having any advice, any suggestion how this can be attempted, or you have done it, you can tell also.
Not getting, sir.
Okay, not getting. So what happens over here that left is sine and right is cos. So one thing which you can think is, can we change the cos on the right side as sine? So cos A can be written as sine of something or not?
Yes, sir.
What that would be?
90 minus or plus A.
90 minus A we will write. 90 plus A will also be correct. In second quadrant also sine is positive. In first quadrant also sine is positive. So either we can write 90 plus A or we can write 90 minus A. Both is correct. So there is no issue with that. That is sine 3A could be sine 90 minus A also, or sine 90 plus A also. Now, if we remove sine, then 3A will be equal to 90 minus A, which means that 4A is equal to 90, or A is equal to 90 by 4, which is 22.5 degree. From here, if you remove sine, it will be 3A is equal to 90 plus A, and this will become 2A is equal to 90, and A is equal to 90 by 2, that is 45 degree. So both are correct. Sine A could be 45 degree also, A could be 22.5 degree also. This equation will be satisfied by both. You can verify also.
Finish, sir.
Okay. Prove that cos pi by 8 plus cos 3 pi by 8 plus cos 5 pi by 8. And you know what is pi?
Yes, sir.
It is where
22 by
180.
7.
That is its value, its numerical value, but in degree, if you change it, so pi radian is how much degree? In angles, pi, if you consider as an angle, how much degree it is? It
180
is
degree.
180 degree. Okay. So here we are using pi as an angle in radians. So pi is 180 degree. That means you can consider like pi by 8 is sort of 180 by 8. 3 pi by 8 is 3 into 180 by 8. But if you write it as 180 degree, it will be quite difficult to solve it. So think as pi only. Pi is equivalent to 180 degree, and try to apply allied angle rules in this. Like if it is pi by 2, then it is 90 degree. If it is pi, it is 180 degree. Yeah, any idea how to do it?
Doing, sir.
Okay. Should we discuss or you are still trying?
So can we discuss?
Okay. So this would be cos pi by 8 as it is, and this will be cos 3 pi by 8 as it is. Cos 5 pi by 8 is actually cos pi minus 3 pi by 8, because when you will take LCM, you will get 8 pi minus 3 pi, which is 5 pi by 8. And here it will be cos of pi minus pi by 8. It will be 7 pi by 8. So this will be cos pi by 8 plus cos 3 pi by 8. And then here we have minus cos 3 pi by 8, because cos 180 degree minus theta will be minus cos theta. It is in second quadrant and pi is 180. So it is even multiple of 90. And if it is even multiple of 90, then cos will remain cos. Similarly, cos pi minus pi by 8 is minus cos pi by 8. And then we can say that cos pi by 8 cancels and cos 3 pi by 8 cancels, and this is equal to 0. Now, some more question. Have you understood it?
Yes, sir.
So whenever there is pi as an angle, you have to think that it is 180 degree. It is same as 180 degree. Pi radian is equal to 180 degree. And if pi is as a value, not as an angle, not as a radian, then it is 22/7. So one more question we will discuss, then we'll come to further theory. If A, B, C are the angles of a triangle then show that sine of A plus B is equal to sine C. So if these are the angles of a triangle, what is your suggestion? What should be written? What is the basic thing which is there about the angles of a triangle?
Angle A plus angle B plus angle C equals to 180 degree.
Correct. So from here, can we write that A plus B is equal to 180 degree minus C?
Yes.
So therefore, sine of A plus B is equal to sine of 180 degree minus C. And sine of 180 degree minus C is sine C. Because a 180 is even multiple of 90 degree and sine will remain sine. Second quadrant 180 minus C, it is positive. Now let us come to more formula. What are other formula like tan? If we come to tan, then tan of A plus B is equal to tan of A plus tan of B upon 1 minus tan A into tan B. This is a formula. Similarly, there is a formula of tan of A minus B, which says that tan of A minus tan of B by 1 plus tan of A into tan of B. So write these two formula also. Now, if I give you a question, this is a little bit difficult question, but I hope you would be able to do it. So you have written the above formula. Now, if tan of A plus B is equal to square root of 3 and tan of A minus B is equal to 1 by square root of 3 and A plus B is between 0 degree and 90 degree. A is greater than B. Find A and B. You can discuss also what you are thinking so that I can tell that whether this approach is right or not. So if tan of an angle is root 3, you don't have to apply the identity here, which you have studied. You have to just think that tan of an angle is root 3. So when does tan becomes root 3? At what angle? This was a trick question. Like, it doesn't mean that you have to apply the identity here. Can't you say that what is angle A plus B? At what angle it becomes root 3? Do you remember the trigonometric table which you studied in class 10th also, in class 11th also we studied that? Is it 60 degree? Do you agree?
Yes,
Tan
sir.
60 degrees root 3. And what is A minus B will be?
Tan 30.
30 degree, correct? So you know A plus B, you know A minus B. Now it is no more difficult. Just add 1 and 2. And what will happen? B will cancel. 2A is equal to 90, which means that A will be equal to 45 degree. And when you subtract from one second one, so 2B is equal to 30. So D is equal to 15 degree. Now, few more identities which are quite important, like sine 2 theta is, which we studied 2 sine theta cos theta. Its another form is 2 tan theta upon 1 plus tan square theta. And then we have cos 2 theta. It has many forms, like one is cos square theta minus sin square theta. Another is 2 cos square theta minus 1. Another is 1 minus 2 sin square theta. And one is 1 minus tan square theta by 1 plus tan square theta. You have to remember all these identities. And then tan 2 theta. So tan 2 theta is 2 tan theta by 1 minus tan square. So if we see one question, it says show that 2 sin square beta plus 4 cos alpha plus beta into sin alpha sin beta plus cos 2 alpha plus beta is equal to cos 2 alpha. Just try this once. I'll be back in 2 minutes. Just try. Yes, so let us discuss this question. I hope you have tried, because basically what I want is to try. Even if you are not able to do the question, no issue. But at least you should have tried it, because after trying, your brain gets some type of exercise which increases your IQ and the application quotient. So it is always important to try whether you are able to solve it or not able to solve it. So the point is to try. So I hope you have tried. So what we will do here, we will write this 2 sine square beta. So if you see the above identities, there was an identity here that was cos 2 theta is equal to 1 minus 2 sine square theta. So from here, can we say that 2 sine square theta is equal to 1 minus cos 2 theta? If we shift sine 2 sine square theta on the left and bring cos 2 theta on the right, we can say that 2 sine square theta is equal to 1 minus cos 2 theta. So 2 sine square beta is 1 minus cos 2 beta. This is what we can write it here. Next one is this one. Now we can write cos alpha plus beta as cos alpha cos beta minus sin alpha sin beta, right? And this is sin alpha sin beta outside, and plus cos of 2 alpha plus beta. We keep it as it is right now. We will see what we will do with it. So this is 1 minus cos 2 beta. We open the bracket and we get 4 cos alpha cos beta into sin alpha sin beta minus 4 sin square alpha sin square beta, like this. And then we have plus cos 2 alpha plus beta. Next step, this 4 cos alpha cos beta sin alpha sin beta basically is actually, if we see an identity here, this identity which we proved also, that sin 2 theta is 2 sin theta cos theta. So according to that identity, sin alpha into cos alpha into 2 is sin 2 alpha, and sin beta into cos beta into 2 will be sin 2 beta. So we can write it like this. And this is minus 4 sin square alpha sin square beta. And also we open this. So this will become cos 2 alpha cos 2 beta minus sin 2 alpha sin 2 beta. That is the identity of cos A plus B. So 2 alpha 2 beta are A and B. Here it is 1 minus cos 2 beta. So what we come across is that this sin 2 alpha sin 2 beta and this sin 2 alpha sin 2 beta are of opposite sign. They get cancelled. So we get this. Now, this is fine. Okay. So one thing more we can do. This 1 minus cos 2 beta I'm not writing. Instead of that, I'm keeping it as 2 sin square beta as it was given. Okay. So this comes from little bit of practice, that whether we have to write it like that or keep it as it is. So because if we keep it as it is, from this term and this term, you can take 2 sin square beta as common, and you will get 1 minus 2 sin square alpha inside it. And this is cos 2 alpha cos 2 beta, another term. After writing this, 1 minus 2 sin square alpha is cos 2 alpha. So this is 2 sin square beta into cos 2 alpha and plus cos 2 alpha into cos 2 beta. Is it clear till here? Yes?
Yes,
Is
sir.
it? Okay. Now 2 sin square beta, I will give you the time to write it also. Now cos 2 alpha can be taken common from both of them. And it will be 2 sin square beta plus cos 2 beta. Again, the same identity which we are using above also, that cos 2 theta is equal to 1 minus 2 sine square theta will give us cos 2 theta plus 2 sine square theta is equal to 1. So this will be basically 1. So it will be cos 2 alpha, which will be your answer, which is the right hand side, which you have to prove. So from here. So you have to remember the identities and you have to apply these identities. And how can you be able to apply these identities? By practicing more and more questions, trying more and more questions. Should I scroll down or done till here? Yes.
Yes, sir.
So these are some of the basic formula which are being applied in trigonometry. And there are some more formula there. There are a lot of formula in trigonometry. So there are some more formula. In the next class, we will see more application and more formula. Written everyone? Hello. Okay, okay. So we are concluding today's session. We'll meet again for JEE class. And I hope that you will keep on trying questions. All the best and thank you for joining.